Hi judges, we're Team SAR. My name is Ricky, and I'm a sophomore majoring in data analysis.
My name is Sabrina Sliger, and I'm a first-year student, double majoring in computer science, engineering, and Chinese.
My name is Audrey Malquit. I'm a first-year student majoring in electrical engineering with a business minor. This past weekend, we participated in DataFest and were handed the challenge of analyzing data for the greater good. In particular, our dataset came from Stormont Vail Health, a healthcare system that has served Canvas for more than 130 years of excellence. Our data consisted of some basic patient information, with privacy protected of course, consisting of factors like diagnosis, encounter, birth year, grouping, etc. With this data, we rose to the challenge of defining a patient's journey, hoping to optimize the patient experience and bring better healthcare to all through our analysis.
Hospitals collect a large amount of data. Once we were handed over 1 million lines of patient data, it was up to us to interpret it geographically. To address this, our team developed an interactive website that visualizes hospital and patient data across Kansas. Our solution transformed messy data into an easy-to-use map, allowing users to explore trends and make decisions backed up by data.
After hours of cleaning up the real-world data, we made a healthcare dashboard to streamline the data and make it easy to access. The dashboard is made up using preloaded aggregated census block features and hospital locations in parallel, so one map can show multiple different things at once. And support interactive lasso selection on the map so analysis can explore multiple areas without leaving the page. On the back end, rather than doing a heavy runtime server, we use Python-driven data pipeline to normalize and join raw cleaning extractions into compact JSON and CSV files to serve as a static asset for easy processing and analysis.
This current page offers an overview of all of the data, summarizing patient number, total encounters, average visits per patient, office visits, and hospital visits. We also analyzed the demographics and displayed the age distribution, with the conclusion of more prevalent diagnoses of joint pain and inhibited movement coming from the older generation. Below that is the race and gender distribution as well. The next page allows you to filter by department and view the statistics belonging to that particular department. These departments are all of the departments that have over 8,000 patients. In each of these statistics, you can clearly see the top diagnoses by frequency for you to be able to better staff each department.
Our cover page features a quick summary of statistics across the top ribbon of the page. The settings to the far left of the screen allow the user to pick how to view the information, with choices like how to filter the information. The map is also interactive, allowing you to click on a blue dot on the map to view the data associated with that region. There's a key to the map as well, with different colored and shaped dots representing different densities of patients. The numbers on the map represent each hospital. The statistics associated with each dot include the GOID, number of patients, encounters, and average visits per patient. Further, the stats also break down the percentage of each age group, race, and gender who make up the total number of patients. Underneath that, our dashboard displays the top diagnoses for that location. There's also the added functionality of a lasso select, allowing the user to draw a polygon over an area on the map to assess more than one data point on the map. For the lasso selection, the count, patient total, and encounters appears as summary for all regions selected. Also, the top diagnoses for the regions within the lasso are also shown.
The map itself, from a cursory glance, can tell us a lot about how we can reform the healthcare system. The hospitals are concentrated in one area, with most of the patients centered around these locations. The hospitals serve the surrounding population very well, but for patients who hail from outside this relatively small radius of healthcare, they're not so lucky. The disparity of healthcare for rural regions is highlighted in this map, as well as the concentration of certain diagnoses for specific areas, leading to potential conclusions like the addition of specialized clinics to treat those specific ailments.
From this, developers can determine whether there should be specialized clinics implemented or targeted healthcare providers placed. For example, we can see a high frequency of diabetes in this region. Therefore, there is a higher need of diabetic support and management resources locally. These interactive tools provide useful insights into patients' needs and experiences according to their geographical location. Researchers can answer questions like where are patients traveling from for care, what health issues are most prevalent in specific regions.
Thank you for watching our project demo. Our team had a great time designing a solution to provide smarter data-driven healthcare decision.